In this video we'll look at the fundamental theorem of algebra, which states that for any polynomial of degree n there must be exactly n zeros. So a quadratic has 2 zeros, cubic has 3, etc. And we can write that polynomial in the form where a plus bi are those zeros. Properties of real polynomials. The first one, you have a polynomial of degree n. It can be factorised into n complex linear factors. And the second one, you can express any polynomial as a product of its factors, and they'd be either real linear factors or quadratics that don't factorise, so irreducible quadratics. Third one, every real polynomial of degree n has exactly n zeros. Fourth, if we have a complex zero, then its conjugate must also be a zero if we have a real polynomial. And the final one, every real polynomial of odd degree must have at least one real zero. And if you recall your work on quadratics and cubics graphs, then if you have the shape of a cubic, such as that one, you have your x-axis, then it must at least intersect the x-axis once, twice, or 3 times. But there's at least one real solution, so one real zero. First example, we've got negative 3 plus I is a 0, and our polynomial p of x is real, and therefore, if that's a 0, its conjugate is also a 0. So negative 3 plus I is a 0, that implies negative 3 minus I is also a 0. And those pair of zeros come from the one quadratic factor, so we work with the sum and the product of those zeros. So the sum of the zeros is negative 6, the product of the zeros will be the sum of 2 squares, which will be 9 plus 1, which is 10. Therefore, the quadratic factor that has these conjugate pairs of zeros will be x squared, take the sum, becomes plus 6x, plus the product. So therefore, p of x can be expressed as x squared plus 6x plus 10 multiplied by some linear factor to get this cubic. So, if I've got x squared times by x here, to get ax cubed, it must be ax. My constant term, 10 multiplied by this constant, must equal the negative 30, so it must be negative 3. Now, in order to work out a, if I expand this expression here and equate it to p of x up here. Now, once again, I'm not going to expand the whole thing, just consider the coefficient of, say, x squared. To get an x squared term, I'd need to have x squared times by a constant, or an x times by an x. And that must equal my x squared term up here, which is 9. If I solve that, I'll get 6a equals 12, I'll get a equals 2. Now we should check to make sure that that answer is consistent, so I'm going to work out the coefficient of, say, the x. Alright, so the x term is going to be x times by constant, and x times by constant, and that must equal my x term up here of a. If I solve that, I get 9a equals 18, and I get a equals 2 again. I get the same solution for a. So let's write p of x, replacing a for 2, which gives me those pair of factors. The question says find all the zeros, so I know that one pair of zeros are the conjugate pair, so minus 3 plus or minus I, and then from this factor here, the 0 would be negative, make it positive, 3 on 2. So they are your zeros. Second example, once again we have a cubic here, which is real, and we've got 1 0 is purely imaginary. So we don't know what that is, so let's let that 0 be ki. Now, if ki is a 0, its conjugate, minus ki, is also a 0. And once again, we can work with the sum and the product of those zeros. The sum of the zeros will be 0, and the product will be k squared, which means our quadratic factor will be x squared minus 0x plus the product, so x squared plus k squared. And writing px in terms of its factors, we've got a quadratic factor, and there must be a linear factor. Once again, it's going to be a times by x, and then I've got my constant, times with k squared, to make it 15. So if I make it 15 over k squared, they multiply to make 15. And if we expand all of that, we get, and now if we equate that to the original cubic up here, we'll get the a plus 1 must equal the 15 on k squared, and the value of 10, which is the x term here, must equal k squared a. So two equations, two unknowns we can solve simultaneously. So I'm going to rearrange the second equation to get k squared, because then I can replace k squared here by 10 on a, which will give me that, and therefore I end up with, move the a across the other side, I get a half a, so a must equal 2. Now we need to work out what k is equal to, so I'm going to sub a back into my second equation up here, so sub into number 2, so I get k squared is equal to 10 divided by 2, which is 5, and therefore k equals plus or minus root 5. So now we can rewrite p of x by replacing both k and a in this expression here. So k squared was equal to 5, a was equal to 2, 5 times by 3 made the 15 here, so therefore my zeros are going to be plus or minus root 5i from the quadratic factor, and negative 3 on 2 from my linear factor.